Hello my dear friends, and I welcome you for the part 2 of the gravimetric estimation of the sulfate ion. Okay, in the part 1 video I given you the principle behind this experiment, and also I given you the theoretical part about how exactly it has to be executed. So in this part 2, we are actually going to demonstrate this particular experiment in the laboratory. So before we actually start, okay, I want you to go through the entire lab. Okay, that is what is called as a lab tour. Alright, so come on my dear friends, have a look at the laboratory. So here we start. This is what we have, is the weighing balance. As you go ahead, you can see this wash basins. Water is required for all the experiments that is to be conducted. You go towards the side shelves, which are made up of chemicals, the water reagents. Here we go. We have another special side shelves where we have specific chemicals to be used for specific experiments. We have a test tube holder, the gas connections, which is so much vital for carrying out the chemical experiments. Yes, how I think you are enjoying this. Yes? Oh yes. The tour of the lab. So this is, my dear friends, okay, this is what the tour of the lab all about. You got the glimpses of a laboratory, alright? So now we actually start with this experiment. So we start with a practical demonstration, my dear friends. This is the given solution of sodium sulfate. Okay, so what is the first step is, we are going to dilute it with distilled water up to 100 ml. So let us hold this standard measuring flask to our eye level. This is distilled water, so we are going to dilute it till 100 ml. Please make sure that you are holding the standard measuring flask to your eye level so the dilution is proper. Yes. Okay, this is done. In our pocket, this is 100 cm cube. Just shake the solution so as to result in homogeneity. So this is our 100 ml of a diluted sodium sulfate solution. Now we are going to pip it out. The second step is pipping out of 50 ml of the diluted solution. This is a 25 ml of a graduated pipette, but if you can see, it's quite thick enough. You can see the nozzle, it cannot go inside directly. So what are we going to do is, we are going to transfer this diluted solution into the beaker. Okay, here we go. Okay, this is the diluted solution. Now, this is the beaker in which we are going to transfer 50 cm cube. This is 25 cm cube, so we are going to pip it out twice. So this is the first 25 ml. You go for the next 25 ml, so that is total is 50 cm cube of the diluted solution. Alright. Now what we do is, the next step is addition of barium chloride 30 cm cube dropwise with constant stir of barium chloride. This is barium chloride, my dear friends, 30 cm cube, 10%. So we are going to slowly do the addition, and you can see the changes which is going to take place now as soon as it comes in contact. Can you see this? Yes. This is the indication of the precipitate of barium sulfate, which is white in color. Okay, can you see this very well? It's a visible change taking place, an indication of the formation of a precipitate. So very slowly, drop by drop, with constant stirring, the barium chloride has to be added. Here we go. So this is about the barium sulfate formation along with what? NaCl. Can you just check it out? Alright. Now, the next thing what we need to do is, after this, is the process of digestion. So here we go for the process of digestion. This is, my dear friends, what the assembly is. Okay, we have a tripod stand, we have a water bath, inside which, okay, we have a pipe clay triangle. You can just have a look at it. Alright. Now we are going to place this on the pipe clay triangle, and we are going to start heating it. And here we go, and that's going to be around for 20 minutes, just making sure that we are going to cover it during this process so as to avoid any entry of the foreign materials into the beaker which is containing our precipitate. Alright, so this is the way the arrangement is, and it has to be carried out for around 20 minutes. I hope you have understood up to this. Now, my dear friends, in the meantime, when the digestion process is going on, we are going to weigh this workman paper 42, as I already told you, alright, in the demonstration in the theoretical part. So, here we go. The weighing balance, initially it is going to be 0, 0. We are going to place this workman paper. I have cleaned the pan of this balance so that no impurities stick to the filter paper. And you can see the weight is 0.820. Okay, it is 0.820. Now, the next thing what we are going to do is, we are going to fold this workman paper. How are we going to do this? This is the first fold. Next is we go for the second fold. And then one side on one and 3 on the other side. This is the glass funnel that we are going to use. Okay, and we are going to insert into it. Now, because this is in a dry state, so it becomes difficult. See, it happens like this. Alright? So what we do is, we slightly moist this. So you can check it out. It sticks to the sides of the funnel. Alright? Right, so as far as the digestion part is concerned, it's being done. So we are going to put off the burner. Now, very slowly, we are going to put this hot beaker onto a asbestos sheet. Now you can check it out over here. See what happens is, I already told you what is the purpose of digestion theoretically. Now you can practically check that all the precipitate of barium sulfate, the white color precipitate, settles down, and this clear solution is going to be at the top. And you also know, my dear friends, what is the composition of that clear solution. Oh yes, it's going to be NaCl. So let us cool it for some time, and then we can proceed for the process of filtration. Okay, so now this is sufficiently cool, So first of all, what we do is, as much as possible, we'll try to take the supernatant solution. So the filtration process is going to be fast enough. It's a clear solution, so it speeds up. The process of filtration. Now see, we have done the entire filtration process, okay, and also the washing part. Now the filtrate that we have is supposed to be what, NaCl. We'll just check it out, the presence of sulfate ions into the filtrate. We have barium chloride over here, so I just add few drops of barium chloride and see this. You don't get a precipitate. So it is very clear that all the sulfate ions are going to be on the precipitate, on the filter paper. Alright, now we proceed for the next step. We are almost coming towards the end of the experiment, my dear friends, and that is, we are now going to dry this on a cone. So have a look at this particular assembly. We have a wire gauze which is going to be put up on the tripod stand, and this is the cone which I am referring to. So I will be putting this filter paper along with the funnel on this cone, and we'll start with the burner. We'll try to cover it also with the filter paper so as to make sure that there is no impurity going inside it, like this, and see how to check whether the drying is done. See right now, my dear friends, okay, the filter paper is wet and therefore it is going to stick to the sides of the funnel. Alright, so now the drying has to be carried out till that particular part so as to we can easily rotate this entire filter paper. Once we are in a position to do the entire rotation, it is a clear indication that the drying process is completed. Alright, so we'll just keep it as it is for some time. Now we'll just check whether it's dried or not. As I told you, see, this is the way we can do it. Can you see this? We can now completely rotate this filter paper. Okay, can you see this? So this is an indication that it is dried completely. Okay, so now we will put off the burner and we proceed towards the weighing. Now we can start with the weighing part. The final weighing, it is W2 as I mentioned. So you can check this weight, it's 1.780. So we had W1 as 0.820 and this is 1.780. So if we find out the difference between the two, we get as what? 0.960. And my dear friends, this 0.960 is going to be the weight of BaSO4. I hope you have understood up to this very well. So yes, my dear friends, we move on to the last part of this particular experiment, and that is about calculations. Now before we actually go into the calculations, let us first of all understand the reactions, from which we will understand the stoichiometry of this reaction. So the reaction was, we have initially sodium sulfate, Na2SO4, and then if you remember, slowly, drop wise, we added barium chloride. So Na2SO4 and BaCl2. that results in BaSO4 and NaCl. BaSO4 is going to be what? A precipitate. Alright? Now, if we are going to balance the reaction. So, balancing reaction is very simple. This is going to be 2 NaCl. Now, we need to find out the stoichiometry between Na2SO4, BaCl2 and BaSO4. Because NaCl is not required in this particular experiment. If you remember, we have filtered it off. So if you can check the stoichiometry of this reaction, it is all 1:1. Alright. So BaCl2 1 mole corresponds to BaSO4 1 mole corresponds to Na2SO4 1 mole. Alright. Now what we do is, once we know the mole ratio very well, we have to convert it into what? Mass. So how to find out the molar mass? Very simple, my dear friends. We need to first of all understand the atomic masses, and on the basis of that, we will be finding out the molar mass. So the atomic masses are: sodium is going to be 23, sulfur is going to be 32, oxygen is going to be what? 16. And one more thing which I want to tell you is that here the sodium sulfate that we are using, it's going to be along with 10 water molecules. So actually it will be considered that also, because 10 H2O. So H, you know, the atomic mass is 1. Alright, so this is what the stoichiometry is all about. So the weight of the residue that we got, okay, weight of residue, which was BaSO4, and if you can recollect, that weight was 0.96, okay, grams. Okay, it was 0.96 grams, right? Now this 0.96 grams, my dear friends, was obtained when we have taken 50 cm cube of the diluted sodium sulfate solution. So what we say is 50 cm cube of the diluted Na2SO4 corresponds to 0.96 grams. Okay, that was W2 minus W1. So now, if you go for 100 cm cube, that was the stock solution, I'll write down as SS. So that is equal to 0.96 into 2. So that is equal to 1.92 grams. 1.92 grams. Now, as we go for the proportion part, so BaSO4, the molar mass of BaSO4 is 233.36. This is the molar mass of BaSO4. Okay. Now that corresponds to 1 mole of SO4 2 minus the sulfate ion, which we are interested in, my dear friends. So that is going to be what? 96 grams. Okay, 96 grams is of SO4 2 minus. Now, from the stock solution, what was the stock solution we have? Na2SO4 along with 10 water molecules. Okay, so it comes out to be 322. Okay, this is going to be the molar mass. Okay, so 322 grams for Na2SO4 10H2. Okay, so now if 233.36 grams of BaSO4 corresponds to 96 grams of sulfate ion, 322 grams of what? Na2SO4. So, how much is the weight of BaSO4 we are getting over here for the total stock solution is? Yes, it's 1.92. So, therefore, what we say is 1.92 grams should correspond to how many of sulfate ions? So, simple is cross multiplication. So, we have 1.92 into 96 divided by 233.36. This is going to give me the concentration of sulfate ion. That will be equal to, what I am going to do is 1.92 multiplied by 322 divided by 233.36. So this is going to give me the amount of sodium sulfate 10H2O. This is going to give me what? The amount of sulfate ion. So if you are going to calculate this, we get it as 0.7890 grams for a sulfate ion, and for Na2SO4 10H2O, we are going to have 2.649 grams. Okay, now this is about sulfate ion concentration. We now go a step ahead. Our job is done. Okay, we need to quantitatively analyze the sulfate ion present in the solution. So that is what 0.7893. We'll go a step ahead, and that is to find out how this experiment we have performed with respect to what error. Okay, lesser the error, greater is going to be the efficiency. Right? So we go into percentage error. So percentage error, for that we need to have the theoretical value. Okay, the theoretical value, my dear friends, is 0.78. Okay, so I just write down over here. The theoretical value is 0.78. So percentage error will be 0.7890 minus of 0.78, the theoretical value, divided by 0.78 multiplied by what? 100. Okay, this is what we have. Okay, this is the percentage error. Once again I repeat, 0.7890, that is the experimental value we are having, minus of 0.78, that is the theoretical value. Okay, that will be always being provided, because without which it's not possible to find out the percentage error, divided by the theoretical value, that is 0.78. And that you multiply by 100, because this error is being expressed in terms of what? Percentage. So if you calculate this, you get it as 1.15. So this is the percentage error. Okay, so it's not that hard. So therefore we say that the efficiency of, because this percentage error is low, so efficiency of the process is high. So percentage error is 1.15, and as far as the quantitative estimation of the sulfate ion is concerned, we have 0.7890. Alright, so this is it, my dear friends. This is the entire experiment that we have considered with respect to the quantitative analysis of sulfate ion. I hope you have understood this very well. Please go through the first part of the video also, and then go for this part of the video for the complete understanding. So thank you so very much.